solar spacecraft to make its first Earth flyby after 17 years. NASA's Stereo emission spacecraft will travel between the Sun and Earth this Saturday, August 12. After nearly 17 years, a spacecraft will make a flyby past its home planet, Earth. NASA's Stereo spacecraft will travel between the Sun and Earth this Saturday, August 12. According to the space agency's official release, this first visit to the Earth presents a unique opportunity to learn more about our nearest star. On October 25, 2006, NASA launched the Solar Terrestrial Relations Observatory mission, STEREO, to investigate and collect data on the Sun's dynamics and immediate surroundings. STEREO-A will achieve such 3D viewing by combining its observations with those of NASA's Solar and Heliospheric Observatory, SOHO, and NASA's Solar Dynamics Observatory, SDO. As the spacecraft's distance from Earth changes throughout the flyby, it would be possible to catch various sized solar features at different times using its stereo vision. The spacecraft flyby coincides with the ongoing active phase of the Sun as it approaches solar maximum in 2025. In this phase of the solar cycle, Stereo-A is going to experience a fundamentally different Sun. There is so much knowledge to be gained from that, said Lika Guhathakurta, Stereo program scientist at NASA headquarters in Washington, D.C. The flyby will enable scientists to take much-needed observations of solar activity, hoping to uncover 3D information about the Sun that is typically lost in 2D photos. The Stereo scientists aim to collect data mostly on active areas and the magnetically complicated regions underneath sunspots. Additionally, they'll also collect evidence on the recently postulated coronal loops, gigantic arches visible in close-up photographs of the Sun. There is a recent idea that coronal loops might just be optical illusions, said Terry Kucera, Stereo project scientist at NASA's Goddard Space Flight Center in Greenbelt, Maryland. Astronomers suggest that our limited viewing angles cause things to appear to have forms they do not actually have. If you look at them from multiple points of view, that should become more apparent, Kucera added. The Stereo mission. The mission initially consisted of two nearly identical spacecraft, Stereo-A, where A stands for ahead, and Stereo-B, behind. On the other hand, Stereo-B lost touch with mission controllers in 2014. NASA notes that soon after the launch, the duo accomplished one of their primary objectives, recording the first stereoscopic image of the Sun. On February 6, 2011, the duo achieved a landmark milestone when the Stereo-A and B reached a 180-degree separation in their orbits. The observations provided the first comprehensive image of the Sun as a full sphere. Prior to that, we were tethered to the Sun-Earth line. We only saw one side of the Sun at a time. Stereo broke that tether and gave us a view of the Sun as a three-dimensional object, said Guhathakurta. Over the years, the mission achieved many more scientific feats, including charting the flow of energy and matter from the Sun to Earth. The remaining satellite continues its voyage around the Sun, capturing views of the Sun that are unavailable from the Earth. Thanks for watching.